Fuentes, and today I'll be going over AB 2012 problem number 1. Okay, so the temperature of the water in a tub at time t is modeled by strictly increasing twice the differentiable function W, where W of t is measured in degrees Fahrenheit and t is measured in minutes. At time t equals 0, the temperature of the water is 55 degrees Fahrenheit. The water is heated for 30 minutes beginning at time t equals 0. The value of W of t at selected times t for the first 20 minutes are given in the table above. Okay, so part A, use the data table to estimate W prime of t. Show the computations that lead to your answer using correct units. Interpret the meaning of their answer in the context of the problem. Okay, so we're asked to find W prime of t, or 12, and we have given values which give us W of t. So we need to find derivative means slope, and so we would need to find the slope of 12 or at t equals 12, and we're given these values, and so since we're looking for 12, we only care about at t equals 9 and t equals 15. So we take these two and put it in terms of x and y, and so we have them as points as so, and so you plug them in, or you find the slope of the slope between the 2 points, and you should get your answer. So y2 minus y1 over x2 minus x1. So y2 67.9 minus y1 was 61.8 over x2 minus x1 50 minus 96, and you plug that in your calculator, you get an answer of 1.017. You get 1 point for estimating this answer. You need to interpret the answer. Okay, so this answer of 1.017, it tells us, since we found W prime of 12, this gives us the rate of change, or this gives us the water temperature, or this tells us that the water temperature is increasing at a rate of approximately 1.017 degrees Fahrenheit per minute at time t equals 12 minutes. Alright, part B. Use the data on the table to value the integral from 0 to 20 using correct units. Interpret the meaning of the integral in the context of this problem. Okay, so it's asking us to find from t equals 0 to t equals 20. We go to our table, we're given at t equals 20, it's 71 degrees, the water is 71 degrees Fahrenheit, and t equals 0, the water is 55 degrees Fahrenheit. And so we do 71 minus 55 degrees, and you get an answer of 16. Okay, so using the correct units to interpret the meaning of in the context of the problem. Okay, so we just subtracted or found the net change of the temperature by subtracting the end from the beginning, which gives us 16. And so this tells us that the water has warmed by 16 degrees Fahrenheit over the interval t equals to 0 to t equals 20 minutes. 1 point for estimating the value of 16, and 1 point for the interpretation. Okay, so part C, for 0 to 20, the average temperature of the water in the tub is 1 over 20, integral 0 to 20. Use the left Riemann sum with 4 subintervals indicated by the data in the table to approximate the integral. Does this approximation overestimate or underestimate the average temperature of the water over these 20 minutes? Explain your reasoning. Okay, so in this part, or part C, you need to know the average value formula, which is 1 over b minus a, integral a to b f of x dx. So we are asked for 0 to 20, and so you would plug a would be 0, 20 would be b, so 1 over 20 minus 0 would give us just 1 over 20, integral from 0 to 20 f of x dx. Okay, so we have a 120 here, and so we're asked to use the left Riemann sum with 4 subintervals. And so what you do is, a left Riemann sum only cares about all of the points except the furthest right point, and so we only care about the points from 0 to 15, and we do not care about t equals 0 in this problem. Okay, so what we would do is we would take these points 0, 55, 4, 57, 9, 61.8, 15, 67.9, and you plot it on a graph. And so you would get the points here, and you can see that this is it's increasing. The curve is increasing, and you would draw your rectangles, your left rhyming sum, and the area of these rectangles is length times width, and the width from this first rectangle is 4. The width is 4. The length is 55. For rectangle 2, the width is 5, and for the rectangle 3, the width is 6, and the length for rectangle 2 is 57.1, and the and the length for rectangle number 3 is 67.9. So what you do is you multiply the length times the width for each one of these, and you get the area, and you just add them all together and you get the area. And then we go back to the problem and we see that oh yeah, so it's asking for the average water temperature, and so we still have we have to multiply it by 1 over 20. So we multiply the area. In this case, we would have 4 times 55 plus 5 times 57.1 plus 6 times 61.8, 5 times 67.9, and we get 1,215.8 times 1 over 20, and you get an answer of 67.79. We get 1 point for just using the left rhyming sum, and we get another point for getting the actual answer, and you get a third point in which we explain that it is an underestimate. The answer 60.79 is the underestimate because if we go back to the picture, the curve is increasing. This is a way better picture. It's increasing, and left rhyming sum gives us the area underneath the curve, and because we found the area underneath the curve, and the curve is increasing, it is an underestimate, and you get 1 point for that. Okay, part D. For 20 to 25, the function w that models the water temperature has the first derivative given by w to the power of t, and you have 0.4 root t cosine 0.06 t. Based on the model, what is the temperature of the water at t equals 25? Okay, so we know our intervals from 20 to 25, so we could. This is another integral, and our integral would be from 0 to 25 of w prime of t d of t. And so what we do is we take the integral, or we go in our calculator and we type do the integral of this from the interval 20 to 25, and then you get an answer of 2.093155, and then that gives you the difference from 25 and 20. And so since we have the difference between 25 and 20, or we have 25 and 20, we were given the water temperature, we still need 20, and so we go to our table. Our table gives us the value of 71 degrees Fahrenheit for the water, and so we would add that to our answer from the integral. So our answer from the integral is 2.093155, and we add 71 to it, and our total answer would be 73.043. You get 1 point for the integral, and you get 1 point for the answer.